Good morning, good afternoon, or good evening, depending on where in the world you are today. My name is Amanda, and I want to welcome you to this TechStrong learning experience. We're welcome and we're excited to have you join us today with today's program and our speakers and topic. Just a few reminders before we get started. This session is being recorded and will be available afterward on demand. We will send you a link to your inbox after we conclude the live program. We also invite you to join us in the chat. We want to engage with you. Feel free to ask your questions in the Q&A panel on the right side of your screen. And feel free to comment, ask questions, and let us know what your comments are on today's topic. And then also, we have great handouts available. This can be found in the resources section under the left side of your screen. Feel free to download those. Those are yours to keep. And today, we're going to have a great topic, great speakers. We have the folks back from Gremlin, excited to have them join us. Let's go ahead and kick off today's topic, and then we'll get started with everything. Today's topic is building resilience from architecture to production with AWS and Gremlin. We are joined by two great speakers, Andre Newman of Gremlin and then Dylan with AWS. And I wanted to thank both of you for joining us. Andre, do you want to go ahead and get us started?
For sure. Yeah, thank you, Amanda. Appreciate it. So welcome, everybody. I figured I'd start with the quick introduction of us. My name's Andre Newman. I'm a Senior Reliability Specialist here at Gremlin. I'm joined by Dylan Sauvage, Partner Solutions Architect at AWS. Dylan's going to talk about what reliability looks like on AWS, and I'll be talking about how this works in practice with Gremlin. So a quick look at our agenda for today. We're going to cover a few different points. First is kind of diving into why is resilience important. And really it's because, or rather why you need to focus on architecting, building, and testing resilience. We'll look at building resilience on AWS. We'll go over best practices, what resilience in AWS looks like and for its various architectures. We'll dive into resilience testing and risk detection. So how do you find reliability risks, not just in their production, but across your SDLC and across all your systems? We'll dive into a couple of demos. Dylan will show you a bit of the AWS best practices on AWS, and then I'll be showing about how you can test for those best practices using Gremlin. And then we'll leave the rest of the time available for Q&A. So to jump right into it, and this is just setting ground level, I'm sure a lot of you understand why resilience is important, but we really just need to drive home the fact that uptime and reliability are non-negotiable. Right? In modern systems, in the modern world, customers and users expect our systems that we maintain to be available where they want it and when they want it, which means 5 nines of availability is a new standard. And if you haven't been keeping up with your nines, 5 nines leaves you with just 5 minutes of downtime every year. So that's an insane amount of uptime, but it's the kind of reliability that customers are expecting. And the unfortunate reality is that we have a lot of really smart people working on this problem, but a lot of companies just aren't hitting that number, and it's having a noticeable impact. So for example, Square had an 18-hour outage, and that resulted in, of course, a ton of negative press and also 27,000 customers that were impacted by that. Citi is working on business continuity compliance. They end up getting hit with a fine because they weren't able to meet that. And then we have airlines who, as I'm sure a lot of us are aware, if you've been traveling especially, canceled flights are always a pain, and they have really material costs, sometimes in the hundreds of millions. So there are some very real risks here in not achieving reliability goals. And the reason that this is so difficult and why this is such a problem is that systems are complex, and they've become what we call a minefield of reliability risks. And what this means is that there are these different risks to your reliability that are hidden and tucked away in all these different parts of our system, and it's really hard to uncover those. Like some of the examples are, you might have dependencies that you're not aware of or haven't mapped out that could impact your critical services. You might have tried to configure auto-scaling, but it doesn't kick in when you need it, or it doesn't scale back down when you don't need it, which will drive up unnecessary costs. There are missing or broken redundancies that have never been identified, like redundant DNS servers, or even just redundant hosts or containers that weren't deployed the way we expected them to. And then there are those untested resilience hacks, the one-off somebody SSHing into a server and doing a quick fix that really hasn't been tested that well or designed for ongoing use, and it's just kind of sitting there. And then we have things like non-compliant architecture that's not well documented or well understood. Maybe something that somebody did as a weekend project that got folded into our production systems and we just haven't decided to go back and refactor that yet. And it's not that any of these are intentional or malicious or done by design, but our systems have honestly just become more complex than our mental models can handle. And they just introduce all of these risks as a result. And these risks can really disrupt our users' lives. So what we're trying to promote at Gremlin and also with AWS is building resilience into the SDLC from every step, from design all the way up to production. This starts with a culture of reliability. That means getting your teams, your engineers, and even your management and C-level on board with this idea of promoting reliability as a practice, taking best practices from companies like AWS, like their well-architected framework, and applying that to your services. And then, of course, as you go through your SDLC, making sure that you're focusing on reliability and doing things like reliability testing and risk detection to ensure that you're able to catch these before they actually have a chance to go live and impact your customers. And ultimately, this culture of reliability is the goal. Right? We want to make it ingrained in our daily practices so that when engineers come in, they're thinking about reliability, they're working towards reliability, and ultimately, they're deploying more reliable systems. So now I'm going to hand it over to Dylan to talk about reliability on AWS.
Awesome. Thanks, Andre. Just want to make sure everyone can see my screen here. Andre, does it look okay?
Yep, you're good.
Awesome. Thanks for that. That was a great overview on reliability and the importance. And today, I really echo the outages and how it impacts users, and we've really seen that at AWS and at Amazon as a whole. So today, I want to talk about reliability and how you can actually reduce your operational overhead while improving reliability. I don't want them to necessarily. I want this conversation to really be about how we can do both at the same time. But first, I want to take a minute and define what reliability means to us. So resilience is all about enabling your workloads to recover quickly from disruptions. At AWS, resilience is built into the foundation of our services. So we focus on 3 core elements: high availability, disaster recovery, continuous improvement. High availability involves designing systems to withstand common failures. AWS tries to make this easier by abstracting underlying infrastructure. As an example, with EC2, AWS manages things like CPU, hard drive failures, so your instances keep running with minimal disruption. Features like auto-scaling are built in to dynamically adjust resources as needed, replacing unhealthy instances. This way, you can automatically maintain service continuity. Disaster recovery steps in for those larger, more rare failures that high availability alone can't address. So, AWS provides tools like backup and recovery across regions. So if an entire site goes down, you have a recovery plan in place to get back online swiftly. Think of it as an added layer of insurance. So when a major issue occurs, you're prepared to switch to a secondary site without significant downtime. Finally, continuous improvement is essential. Resilience isn't a set it and forget it concept. This includes, CI/CD, automating that CI/CD deployments, observability to keep tabs on system health, chaos engineering to test for vulnerabilities. When done right, these practices will be ingrained into your engineering culture, where engineers are automatically including resilience planning with their work planning. Continuously refining these practices, we ensure systems are ready for anything. One of the tenets of good application design is to design for failure. I love this quote from Amazon's CTO, Werner Vogels. Folks who've been around AWS for a while have probably heard this before, but everything fails all the time. At Amazon, and by extension AWS, we plan for failure. There's an old saying that if it can fail, it will, and we want to be ready for that and test for failure. Resilient applications provide continuous service despite disruption. Natural disasters, human error, hardware failures, etc. When you're designing for resilience, it's important to think about where things could go wrong. That's what we call resilience threat modeling. There are a few key areas to consider. Andre touched a little bit about some of these before, but just to go a little deeper on them, code deployments and configuration. Imagine a deployment goes sideways or a configuration mistake sneaks in. Is there a system in place set up to detect configuration errors or maybe deviations from standardization? Maybe a credential expires, a TLS certificate isn't renewed on time. Are there monitoring set up to catch these issues quickly? And ideally, does your CI/CD system allow you to roll back automatically if something breaks? Is it being tested? The core infrastructure. This covers underlying hardware and network. At AWS, we do our best to handle a lot of this for you, again, abstracting CPU, et cetera, in EC2. But if there's a bigger issue like an availability zone going offline, you'll want to make sure your application can handle that level of disruption. Data and state. We're talking about your data in the application state. What if there's data corruption or if an instance runs out of memory? Are there alerts in place? Is the system designed to automatically respond in these scenarios? I mean, especially if it could impact your customers. Are you doing manual things like ClickOps? Dependencies. If workloads rely on other services or APIs, external or internal, what happens if a critical third-party API slows down or fails? Does your system gracefully degrade or maybe shift to a backup plan? Highly unlikely scenarios. Again, the extreme cases mentioned before. What if a natural disaster impacts an entire region? Even though these scenarios are rare, it's good to have a plan for how your application would handle something big. You know, AWS, we design our regions and availability zones to be geographically distinct, not be in the same floodplain, but we still want to think about that when we're, architecting for resilience. When we look at resilience, is it clear there are a lot of different types of failures to consider? But who's responsible for each of these areas? I've talked a little bit about how AWS abstracts this for you, but I want to quickly go over the shared responsibility model for resilience. So in AWS, resilience operates on a shared responsibility model where AWS manages resilience of the cloud and the customers handle resilience in the cloud. You may have heard this before with the security shared responsibility model. It's a very similar concept. AWS takes care of the foundational infrastructure, ensuring that the cloud itself is resilient. Again, this includes designing regions with multiple isolated availability zones, each with their own power, cooling, and network to maintain high availability and fault tolerance. These AZs are connected with low latency networks, allowing for synchronous replication, quick failover if an AZ experiences an issue. This infrastructure is designed so that customers don't have to worry about resilience of hardware, data centers, or core networking. AZs are actually at minimum one data center, but often include more than one data center. On the customer side, resilience in the cloud involves designing and managing workloads to take advantage of the foundation that AWS has built. Customers can decide how they want to architect applications, whether that's distributing workloads across multiple AZs for high availability or implementing observability and failure management practices to quickly detect and respond to issues. So this shared responsibility model provides a solid foundation where AWS handles resilience of underlying infrastructure and customers can focus on configuring and architecting workloads that match their needs. And together this approach ensures that workloads can withstand both common disruptions and rare failures. I want to now talk about what it means to be well architected and how the well architected framework can help you guide in designing efficient, secure, cost-optimal, resilient applications. So when you look at the workloads your team is building, can you confidently say they're well architected? It's a question we all need to ask because in the cloud, best practices aren't just nice to have, they're critical to achieving resilience, security, and efficiency. Of course, we all want to say yes. We have skilled teams and we strive to build high quality systems. But as the environments grow more complex, there are common challenges that many organizations face. These include responding effectively to security events, setting clear operational standards, ensuring workloads perform consistently, using resources efficiently without overspending. I think that's a really important one in the context of resiliency and reliability. AWS supports customers in tackling these issues by providing best practices and guidance through the AWS well-architected framework. This framework helps ensure your workloads are secure, resilient, performant, cost efficient. Let's explore a little bit about what it means to be well-architected in AWS and how we can help you achieve these best practices consistently across the environment. So what is the AWS Well-Architected Framework, right? It's a comprehensive guide to help you design and manage reliable, secure, and efficient cloud environments. We've structured it around 4 key components: pillars and lenses, design principles, questions, and best practices. First, we have pillars. There are 6 core pillars. I've kind of touched on them a little bit before, but to standardize them, there's operational excellence, security, reliability, performance efficiency, and cost optimization and sustainability. Each of these represents a critical aspect of the well-architected cloud workload. For specific use cases, AWS also offers lenses. Lenses provide tailored best practices for particular industries, technologies. An example of this could be serverless, high-performance computing, DevOps. There are also design principles, guidelines that help you think about architecting in the cloud. These principles guide your approach to building and managing cloud infrastructure, helping ensure that your decisions support the long-term health of your infrastructure. Questions is where you actually evaluate your workloads and answer that question: are you well architected? The framework provides a structured set of questions for each pillar, prompting you to assess how well your architecture aligns with cloud best practices, especially in areas like reliability, which we're going to focus on today. Finally, there are best practices tied to each question. These are actionable recommendations that you can implement to improve your workload's performance, security, and all the pillars. In today's session, we're going to be again focusing on the reliability pillar, and we're going to explore how the well-architected framework can help you build more resilient workloads. We're also going to see how Gremlin can support you in this effort, helping you test, improve your reliability, and ensure your cloud applications stay robust under stress. Let's take a closer look at the reliability pillar, see how it can help you guide your approach in building reliable, fault-tolerant infrastructure. So while there are 6 pillars, we're going to focus on reliability, and reliability is all about building systems that can handle failure and keep running smoothly, even under unexpected conditions. I really want to highlight that, especially under unexpected conditions. It's about having confidence in your systems and knowing that it is resilient and will be available. And the only way to really do this is to test that and have results. So there's a few key design principles we're going to cover about the reliability pillar. So first, we're going to talk about automatic recovery from failure. So you want to design your systems to detect issues and recover automatically, avoiding click ops, avoiding 3 a.m. pings to go and launch more EC2 instances. An example of this would be health checks, failover mechanisms, directing traffic away from unhealthy instances or unhealthy services to keep things running smoothly. Really important, testing recovery procedures. We really recommend that you don't just plan for recovery, but you actually test it. Have regular cadences for testing workloads, and implement tools like Gremlin to simulate failures in controlled ways. This way we can identify weak points before they affect customers. We recommend scaling horizontally. Instead of depending on one large server, spread the load across multiple smaller instances. This way, if one fails, others pick up the slack. Automate changes. Automation reduces human error. This is a common cause of outages. By using CI/CD pipelines, infrastructure as code, we make sure our changes are reliable, repeatable, and recoverable. This one's pretty straightforward, replicating data across availability zones. I think this is really talking about the idea of those larger failures you mentioned earlier, catastrophic failures, right? Storing data across multiple zones helps keep it accessible if a zone goes down. We make it easy at AWS to replicate data automatically, so it's always available when you need it. And by following these principles, you can build resiliency right into the application. Reliability is not a set and forget it concept. Regular testing is essential. In a bit, we're going to walk over how Gremlin can help you put these principles into action with real-world tests to validate your system's resilience. But first, I want to showcase a quick demo of the AWS well-architected tool. So the quickest way to put well-architected framework into practice is to complete a well-architected framework review for one of your workloads using our well-architected tool. I want to point out that we recommend the well-architected tool workload be created in your AWS account, stored securely with least privilege access in mind, with only the right people having access to the workload details. And I also want to point out that workloads can be shared with your AWS Solutions Architect and AWS Account team. So if you're interested in anything I showcase in this demo today, feel free to reach out to your partner resource or your AWS Account team for a collaboration on the review or remediation using workload sharing. Today, we're going to do a quick walkthrough of the tool and a quick overview of a sample report. So I'm going to quickly swap over to my screen here. Can I get a quick check from Andre if you can see my tool here?
Yep, all good.
Awesome, thanks for that. So we're in the AWS console here, and I've created a sample well-architected tool review focused on the reliability pillar. I just wanted to showcase a brief overview of what this is in case you haven't explored it before. So to navigate to it, you can always go to the AWS console and type in well-architected tool. You can click on it. In this case, I already have a workload here. Normally what you'd see is a define a workload button. We already have one. So let's walk through a quick review of what a workload looks like. I've created an example workload for an e-commerce site called Petco. The application is called Shop Fast. I'm not going to go over all of the example details here. It'll take too long, but I'll show you a quick review of what the architecture looks like. I've created a simple architecture here, a 3-tier web app with very basic RDS, relational database service, backup to our Amazon S3 simple storage service RDS backup solution. You can see that this is a single availability zone, and we are vertically scaling and only backing up our data on a semi-regular cadence. To showcase the value of what this is the well-architected framework is a tool that allows you to continuously assess your workloads. So let's jump into what a review actually looks like. So jumping into the continue reviewing button here, go to the well-architected framework, and we're going to focus on the reliability pillar here. So now you can actually see that the well-architected framework tool provides you actual questions along with guidances and resources around the workloads. These are high level. These capture things that sometimes tools can't capture. And some of these are actually around processes and systems that you've built in place that aren't necessarily purely technical. So walking through a quick review here. How do you manage services and constraints, right? So are you aware of service quotas and constraints? Do you monitor and manage quotas? Do you have automated quota management? And what we expect when you run through this tool is that you put in your answers for each of these questions as notes, whether you do have them or don't have them. And for each of these questions, we have information and further reading about each of these and how you can help, for example, build processes and systems in place to help understand them. Do you design your workload service architecture, right? Do you choose how to segment your workload? Do you build services focused on specific business domains and functionality? I want to point out here that these are business dependent, organization dependent, context dependent. These aren't one size fits all. For a smaller startup, maybe it's not a business priority that you deploy in 7 regions and you have failover for all of them. Maybe there's not the resources for that. We have to make sure that you have context when we're going through this. But, set of standards is still help. I want to focus on one here that's really important in today's context. How do you test reliability? After you've designed your workload to be resilient to the stresses of production, testing is the only way to ensure that it operates as designed, delivering resiliency you expect. I've had many conversations before where, testing is, we do it once every year, once every couple of years. But, we recommend automation. We recommend that it be part of, your systems in place. I mentioned earlier in CI/CD. So, testing those functional requirements, testing scaling performance requirements, use chaos engineering, conducting game days, right? So for example, here, we use, in this example, we're using Gremlin. So we have chaos engineering, we do game days, we have functional testing, we do load performance testing, we have, we have comprehensive testing of our single AZ. So I wanted to showcase that it is possible to, maintain this even for, smaller workloads. Finally, I want to quickly showcase what a report looks like. I'm going to generate a report here. There's a lot to the tool, and I'm not going to cover everything today. I just wanted to showcase what the tool is about at a high level. So we're going to generate a report to see what it looks like quickly. And you can see we have now a report with an improvement plan. We have high risk and medium risk identified options. We have the different lenses we selected. Again, we only focused on the well-architected today, but we have more lenses, as I mentioned. And let's jump into the reliability pillar here. And you can see that in this case, we had 11 high risks. Obviously, this is a fake example. Most of the time, you're not going to see 11 high risks out of 13. But today we have 11. This is a fake workload. And you can see that we've identified why it's a high risk based on the selected choices along with all the notes. We also provide further reading, for example, improvement plans related to the things you've answered. And again, we really do recommend working through this with your AWS account team and your AWS partners that you work with. Okay, jumping back over to the presentation, I'm going to pass it back over to Andre for resilience testing and reliability risk monitoring with Gremlin.
Awesome. Thank you. Let me get my screen back up. All right. So yeah, thank you for that run through, Dylan. So Dylan just showed us what well-architected looks like on AWS, but what I'm going to talk about now is how do you get to that point? How do you actually get to not just knowing what you have to do, but being able to run those tests, make sure your systems are holding up to them so you can actually answer those questions with a definitive yes. And the answer is with resilience testing and reliability risk monitoring. So in other words, going back to what I was talking about earlier of uncovering and catching those reliability risks before they reach your customers and cause those incidents or outages. So first, I'll just start with the definition. What is resilience testing actually? Resilience testing is built on an idea called fault injection, where we simulate failures on systems to holistically test their reliability. And fault injection means exactly what it sounds like. It's intentionally creating faults and failures in the system, seeing how the system reacts with the goal of wanting to make improvements. And in the case of computing, this can be anything from consuming excess CPU to test scalability or dropping network traffic to simulate region or zone outages. And of course, we don't recommend you just go around stressing out your systems because that'll stress out your engineers too. We recommend taking a more measured approach. And with our customer base, we typically see two main methods that are being used. First, Dylan talked a little bit about this, is chaos engineering. This is usually one-off exploratory experiments that help find unknown failure modes in your system, things that you might not know are there, but you still want to test for. Chaos engineering is great for that. But then there's also validation testing, which is scheduling and standardizing these experiments so that they run regularly. This lets you do things like track reliability over time, verify that your applications are resilient to common problems, and like with QA testing, being able to uncover regressions so that they don't come back to bite you later. Just as an example, one of our customers had a Redis database set up as a cache. They set it up so that if the cache was unreachable, the system would fail over to the primary database. And it's kind of a pretty standard, uncomplicated setup, but they still wanted to check it to make sure. So they ran a test that introduced latency between the cache and the application, and it browned out. And what ended up happening is that the time before failover was set to be longer than the timeout time, so the failover never actually triggered. And this is kind of a classic example of chaos engineering or exploratory testing. So by thinking about this scenario and creating this custom experiment, they uncovered a weakness. But caching itself is a pretty standard action and can take place all over the system. So now that they know that this is an issue in one place, they can establish this as a standardized test and run it across all of their other different systems and services to make sure that they're not susceptible to. So it's a use case for chaos engineering, but also showing how chaos engineering can more or less grow up, for lack of a better word, to become validation testing. So what kind of failures can you simulate? Well, with Gremlin, we offer these 12 experiments over 3 different categories. So for resource experiments, we have things like CPU. Are you able to stress CPU, and is your system able to scale to meet high CPU demand? Memory is kind of the same thing. If you're low on RAM, is your system able to scale, or does it at least detect that it's low on memory and be able to to maintain the running processes? Disk I/O. If your disk I/O throughput is stressed or your bandwidth is low, is your service still responsive? Is it still able to serve data? And if your disk is filling up, or if it's near its capacity, likewise, is it also able to keep running? For network experiments, we have a lot of very commonly used failures to simulate. Things like DNS outages. I'm sure you've heard the saying, it's always DNS. This is the kind of test that lets you test for that. Black hole is dropping network traffic to an endpoint. So if you want to, let's say, replicate a zone redundancy test, you can actually drop network traffic to an entire availability zone to make sure that your systems are able to fail over. Same thing with latency. If you have let's say, a cluster of EC2 nodes that are and one of them is experiencing higher latency, is your load balancer able to point to a more responsive node to serve the same traffic? Packet loss is kind of the same thing. If the network situation is congested or if there are a lot of dropped packets, are you able to resend the data so that it doesn't get lost or that it doesn't get corrupted? And then we have what we call state experiments, which are experiments that actually sort of modify the state of the system temporarily. So the most common one that a lot of you are probably familiar with is shutdown. If one of your nodes or containers shuts down, do you have a replica already deployed to take over the traffic? And if not, are you able to deploy a new replica automatically? For time travel, if your system clock gets out of sync with another system, are you able to detect that? Does it end up causing problems like with your database? And can you recover from that? Process killer, if let's say a process is killed due to an out of memory issue or because it crashes or whatever it might be, is your system able to restart those essential processes so that they're not just done? And then certificate expiry is one that we added recently. This actually evaluates your TLS certificate chain to see if there are any expired or expiring TLS certificates. And this one's a little different because it's not technically a fault, but it is still really important and is critical to a lot of modern systems. So we still encourage that folks test for that along their dependency chain. And so where and when do you use these tests? And really, to avoid blind spots or false positives, you recommend that resilience testing takes place with real-world conditions across as much of your systems as possible. So of course, for infrastructure, if you're in the cloud, if you're on AWS especially, you're able to run these tests to make sure that you're well architected, that you don't have any missing reliability risks. But you can also take these and run these same tests on-prem. And if you're using Kubernetes or if you're using traditional virtual machines, or even bare metal or serverless situations, Gremlin is here to help you be able to run those tests regardless of where your infrastructure is running. And of course, there's across your SDLC. So of course, production, we recommend testing to make sure that you don't have any issues reaching your customers. But even before that, you should be looking at doing reliability testing during development, and especially when you're in staging. We have a saying that there's no environment quite like production. So ideally, you would bring your testing there to make sure that the issues there get resolved. But if you're not quite ready for production testing, you can always bring this testing into pre-production. That'll at least help you catch a good chunk of these issues so that they don't make it further in the SDLC. And then in addition to active reliability testing, we also recommend what we call reliability risk monitoring. And this is just checking your environment for common configuration errors that lead to failures and outages. Right now, we support two main categories of risk monitoring. First is for AWS Elastic Load Balancers, and second is for Kubernetes. And I won't necessarily go over all of these risks because they're in our documentation and also in our product if you use Gremlin. But essentially what we're looking for are common issues that folks might not think of when they're starting out with either of these platforms, or that you might forget while you're deploying these. So we just essentially highlight these and surface them to you so that you know that these are risks. So just as a quick overview, for AWS, we're looking at things like, is your load balancer availability zone redundant? Does it have deletion protection enabled? For your Kubernetes services, or any of your pods in the crash loop, do you have multiple image versions running for the same service at the same time? Or any of your pods unschedulable? Things that really important to making sure that these services stay up and running reliably is stuff that we also check for. I'll show you a bit about how that works in our demo. So before I actually jump into the demo, just wanted to wrap up the section with a small case study. We actually helped a top 5 US bank migrate to the cloud. And this is just a situation where it turned out reliability testing was a big part of their migration. So quick overview, their migration included 100 million customer accounts that were being moved to AWS. Pre-launch, we were able to help them identify 51 issues. This helped them migrate ahead of schedule and below budget, which is always a nice addition. And then, of course, shifting to that continuous resilience posture. So, for example, taking that reliability testing as a practice, as a one-off, and then embedding it into the company culture so that it becomes a continuous and ongoing thing that's always on top of mind. And honestly, I love this quote. Without Gremlin, we definitely would have experienced P1 issues down the line. It's really nice to hear that we helped prevent a potential outage, especially if it's coming from a VP. That's just some extra validation that, this is really important stuff that we need to be working on. And it's also important that you have the right tools to be able to test for them. So with that, I'm going to jump into a quick demo. So what I'll be showing is, oops, I don't want to go that far, how Gremlin works in practice, not just from a testing perspective, but also applying it to a real world situation. So I want you to imagine for a second that you're an engineer and you're working on this banking website. Customers can log in, they can check their account balance, they can see how much money they have, they can see their transactions. If they want to send money to somebody, they can just click send payment and just say, I want to send $50 to Eve. They click send, and then the transaction appears in this list. Very simple, very straightforward example, but when we look under the cover a bit, what we see is that this one website is actually made up of a bunch of different services. So you have this front-end service, which is the website that you just saw, but behind it, you have things like a user service, which handles user authentication. We have a ledger writer, which writes transactions to the ledger, a balance reader, which pulls transactions from the ledger and consolidates them into a single balance, and then transaction history service that shows all those flows of money in and out. So just to give you a sense of what the architecture looks like, this is what you're going to be seeing as I go through the Gremlin demo. So jumping into Gremlin itself, I'm going to start off with what we call the team score report. This is essentially what you'll see as a day-to-day Gremlin user. This shows how your Gremlin team is doing on your reliability work, and it shows it over a historical period. So I can see my overall reliability score, which isn't particularly great. 38% isn't that high, so definitely want to do some improvements there. But I can also see for each of the services I have running in my environment, which ones have been tested, what the score is, which ones haven't been tested, and also which ones are, have been tested a little bit, but might not have been fully tested, and also whether these tests passed or failed. So if you want to take a closer look at one of these services, let's say I want to look at the transaction history service and see what's been done on that. I'll just go to services. I'll just find transaction history and click on that. Just like that, I can see the reliability score for the specific service. I can see how many dependencies it has. I can also see how many risks we automatically detected, and I'll dig into that a bit more later. But the real highlight of this page is the reliability score and the reliability test down here. And really, each of these tests is designed to stress a single aspect of your system, such as its ability to scale, its hosted zone redundancy, and how well it handles slow or failed dependencies. And together, these tests make up what we call a test suite. And Gremlin gives you a couple of built-in test suites, but you can also build your own. But the one I'm using now is actually called the Well-Architected Test Suite, and it's designed specifically for testing cloud services. So I figured it was a pretty good fit for this presentation. So to give you a sense of what running on these tests actually looks like, let's start one up. I haven't ran a disk IO test on this service yet, so let's do that. To run a test, I just go up, I click run, I confirm, and the test starts running. We can watch it as it starts up. We can see what Gremlin is actively doing and how much time has been spent on it. And the idea behind this is that as long as the service is truly scalable, and as long as it has enough disk IO bandwidth, this should have no impact on availability. We shouldn't see any changes to how responsive our service is or how long it takes to load. And the way we do that is by using what we call health checks. And the health checks is the health check is pretty much exactly what it sounds like. It's an automatic check that happens behind the scenes that looks to make sure that the service is still available and still responsive, right? So I have this health check set up to ping this URL. It's going to look for HTTP 200 status code. and it's going to wait up to 5 seconds or 5,000 milliseconds. And as long as it gets a response that matches at all three of these criteria, then it's still considered passed and the test will keep on running. So essentially think of these as your service's heartbeat. But for AWS, we kind of expanded on our health checks a little bit and created what we call intelligent health checks. These are health checks that hook directly into CloudWatch and don't require any additional setup. Like I showed you this one, I had to configure the HTTP code and also how long it takes. You don't have to do any of this for an intelligent health check. Also, you might notice that the service just failed. So that's not particularly a great sign, but that's something future me can worry about. So to show you what intelligent health checks look like, I'm going to go to a different service. I'm going to go to this front end service. And as you can see, I don't have any health checks added, so it won't actually let me run any tests until I do that. So I'm going to go to add a health check. I could add a regular health check here, but instead I'm going to go to intelligent health checks. And in order to add intelligent health checks to a service, we have to actually map it to an elastic load balancer running on AWS. Previously, before this webinar, I gave Gremlin permission to read my AWS account, so it knows how many load balancers I have deployed. It also knows the services that I have running on the Kubernetes cluster, so it's able to match those two together. So I'll just go to add. I'll make sure my AWS account is selected. I'll click next. And you'll see I have this ELB named the Bank of Anthos front end. I'll select that. I'll click next. And I'll confirm that I want to use intelligent health checks for this service, and I'll click save. And just like that, Gremlin just immediately adds 3 different health checks for this service. One that checks latency, one that checks error rates, and then one that checks our request rates. And the thing is that because Gremlin has access to these metrics, it's able to automatically determine thresholds too. So it knows what is considered good and what is considered bad and what to do if our service falls outside of those thresholds. So from now, I can just go back to my front-end service and you see that all of my reliability tests are available. I can go in and start running any of them, just like I did with the previous service. But I'm not going to do that. I'm actually going to go up here and show you one more thing, which is detected risks. I was talking a bit about these earlier. These are the automatically detected reliability risks that Gremlin can find out just by seeing your service's configuration. And as you can see, we have a bunch of them added already. You're seeing all of them for this service because this service is both an AWS service, but also a Kubernetes service. So as I showed you during the presentation, we have a bunch of detected risks for both, and that's what you're seeing here. So for each risk, we have a status of it can be mitigated, which means that it's not susceptible to this risk. We have at risk, which means that our service is susceptible. And we have NA, which means that this doesn't actually apply to the service, which you might see if this wasn't a Kubernetes service. And if you're not sure, or if you want to get more details about what a risk means, just click on it. It usually should expand out. There we go. It'll expand out below the risk. We'll give you details on what the risk is, why it's a risk, and how you can actually go back and fix it. So that was a quick run through of basically Gremlin. So now I'm going to head back to our presentation and we can start to wrap up from there. Oops, if I can actually hit the button correctly. Sorry. All right, so that was a quick look at Gremlin. And Dylan was able to show us how this process works in AWS with his well-architected tool. So now we're going to actually open up the floor to Q&A. So if you have any questions for either of us, definitely feel free to enter them into the Q&A panel and we'll answer them as they come in. Okay, so it looks like one came in already. Can Gremlin solution test to prevent CrowdStrike-like update failures, whether as a vendor or from the corporate end user perspective? That is a really good one. And I'll say the question's a little complicated. For things like deploying updates, it's a little bit trickier because when you think about reliability impacts, it's more of the outcome of things like that than it is the actual update itself. So the update was distributed and that's what ended up causing the failure. So the way you would approach that from a reliability perspective is that if one system fails, does that cause a cascading failure to a bunch of other systems? So what you can do is, let's say you have a system that's running a critical service that you own, like our front end service. You can use Gremlin to go and shut down that service or black hole traffic to it, and then keep an eye on your other services to see how they're responding. Like ideally, nothing should happen to them. They should be able to keep going despite the outage. But if you see that they're becoming overloaded or they're taking longer to respond or they're also failing, that's how you know that you have a really critical dependency there that you need to work on untangling. So, probably wouldn't have helped with testing the update distribution, but it could have helped with making sure that your other services would stay up and stay resilient, even if one of them fails. Oh, there's a bunch of questions coming in. Let's see. Should we always include all of the risks from that list in our test suites? I'm a little biased, but I'm going to say yes. And the reason for that is that we picked these detected risks based off of reliability best practices, what we've seen working with our customers, and also information published by AWS and their teams and folks like Dylan who have been working on this problem for a really long time. These are common failure modes that you'll see regardless of where you're deploying your services, and in some cases, regardless of what platform you use. So we highly recommend using all of them. If some of them aren't applicable to you, you can remove them by creating a new test suite and just pulling out the ones that you don't want. But we recommend using as much as you possibly can just to make sure that you have full coverage. Another good question that came in is, can you compare AWS FIS and Gremlin? Is FIS an implementation of Gremlin? I can answer that. Dylan, if you have any input, feel free to jump in. But the real quick overview is that no, FIS and Gremlin are separate. FIS is AWS's tool for injecting fault onto the AWS platform. And where FIS is really unique is that because it's built by AWS, it of course has ways to hook into the AWS API to run tests that Gremlin might not be able to. So for example, you can, I think, like remove an RDS database or drop traffic to an RDS database. You can't get that granular with Gremlin just because we don't have access to RDS's API. But what you can do with Gremlin is, let's say, drop traffic from one of your services that might be running on Kubernetes or EC2 to RDS and make sure that it fails over to a secondary database. So kind of an example about how those two compare.
Yeah, I think you really covered the key differences, Andre. I don't really have much to add on that.
Let's see. How do you validate the RTO and RPO are met or not? Any validation flow? I actually have to give that a little bit of thought. So the short answer is that when you're looking at your metrics, like RTO and RPO, that's kind of where our health checks come in. So really what we're looking at is just making sure that your service is, whether it's available or unavailable. And that definition is up to you. So if you want to attach a health check to your SLAs or to an SLI or to another metric that you're running in an observability platform or any other platform, you can do that. We won't check things like how long it takes for the system to recover or how long it takes for your team to respond. That's kind of something that you need to track on your end, or if you have an incident response tool, it's a really great place to do that. But what you can do is you can use Gremlin to test things like your response procedures. How quickly does your team get notified of an issue when it happens? How long does it take for an incident to go from being raised or being triggered to being resolved? The short answer is that there isn't really a direct way to record that information in Gremlin, but Gremlin can still help test for those. Let's see, making sure I'm getting to these in order. Does your reliability algorithm take into consideration the security vulnerability also? Or what is the well-architected QA? So Gremlin is focused on reliability pretty much exclusively. we don't take security vulnerabilities into consideration. This is strictly reliability testing. And I'm not sure if I really understand the second part of that question of what is the well-architected QA. Can you explain that in a little more detail? Or maybe rephrase that?
Yeah, I think that when it comes to security vulnerability, if you're looking at AWS services, you'd look at something like Amazon Guard Duty or AWS Security Hub. I think those would fit more in line. And I don't think that Gremlin, from my understanding, and Andre cut me off right now, is kind of like the same solution.
Right. No, exactly. All right, let's see. How do vulnerability scans and SBOMs interact with Gremlin and WAF to isolate CVE failures in the CVSS scores? And do you interface with patch and new release management? I'm going to be honest, there are a couple of acronyms there that I'm not familiar with, so I'm sorry if I get this answer wrong or if I get confused by this.
I can speak to the acronyms if you'd like. SBOM would be Software Bill of Management. CVSS is Common Vulnerability Scoring System. CVE is Common Vulnerability. Trying to remember off the top of my head. I want to say it's Exposure. It's Common Vulnerability Exposure. These are all security terms as well. Again, obviously that could impact in a reliability context as well. I think that comment's probably coming from similar places, the CrowdStrike comment. But I'll let you answer that one, Andre.
Yeah. So, like, again, Gremlin isn't a security testing tool. That's not what we're focused on. But what we are able to test for is, again, things like outages or systems that are stressed out. So, for example, let's say one of your systems might be under attack and that attack results in heavy CPU usage. You can use Gremlin to replicate that CPU usage to make sure that your systems are still able to, or that your services rather are still responsive even while that's happening in the background. So, while we can't exactly test for security impacts, we can in some ways simulate security impacts.
Yeah.
It's just being done through a slightly different approach.
Andre, I wanted to add on to that just a little bit, and let me know if you think this is a common pattern here. I think that people are coming at this from a security standpoint because they're trying to understand how they could remediate the outages there. I think the key with Gremlin is that the outage reason doesn't matter. It's that it exists. So you can test and simulate failure. From an AWS standpoint, something like SBOMs or CVEs, et cetera, we have tools like Amazon Inspector where you can actually export your software bill of materials. I can post that in chat here somewhere. I don't know where to post that. I'll just post it in the message there. And so you can use tools like Amazon Guard Duty, AWS Security Hub, Amazon Inspector with SBOM to help remediate and prevent those security vulnerabilities. But I think the key here is that Gremlin doesn't care where the issue is. It helps you test and plan for those failures no matter where they come from. From a security standpoint, you're going to have to implement other solutions. Does that make sense, Andre, from your perspective?
Yeah, that's put perfectly. All right, let's see. What type of AWS access is required for Gremlin to use the Cloud Health Check? Great question. So we actually post the full policy JSON on our website. I'm seeing if I can grab the link for that now. Essentially, what we ask for is just read-only access to CloudWatch, a few attributes in Route 53, and then a few attributes in Elastic Load Balancing. And that's just to get things like the status of it, attributes like is deletion protection enabled, things like that. There's nothing that we do that modifies the AWS account. There's nothing that we're changing or no additional services that we're spinning up. This is exclusively to be able to map the metrics from your ELB to a service running on your EKS cluster or EC2 cluster or whatever it might be. So I'll post a link to that chat shortly, but that's how that works.
Yeah, and in general, from our side, we typically recommend that we review the documents for these things in particular, especially if your organization has security, like working with vendors, et cetera, security requirements for the vendors. Like, for example, if the compliance was read-only, et cetera. So we recommend reading those.
Yeah, absolutely. We work with a lot of companies that have really intense security requirements. So we try to make as much of this information available publicly as possible. Let's see. Next question is, presented Gremlin features works for Microsoft Azure as well. Yes, essentially our reliability testing and chaos engineering can be done on any platform, AWS, Azure, GCP, on-prem, whatever it might be. The process applies the same. But for some of the features, like the AWS intelligent health checks and the detected risks, those are AWS only. We are evaluating looking at other clouds, but we wanted to focus on AWS first because, frankly, it's the one that most people use. And also, we really love the AWS team. So that's where we're focused on now. But the general testing practices in reliability testing can work anywhere.
You don't have to just say that for me, Andre. It's okay.
Great question, though. Cool. I know we're already at the 56-minute mark. Are there any other questions anybody else has before we wrap up?
Yeah, I've got, let's see here. Oh, I think most of the ones I had got mostly answered. So that's good.
Cool.
We just got a question about, will we be sharing the recording of the presentation?
Yes. So that's one of the things that we can, I was going to discuss in the closeout, but I will go ahead and share it now. You will receive a copy of the recording here. We will send you a link to the on-demand recording to your email inbox. So yeah, this is going to be available. Don't forget to download the handouts that the team at Gremlin has provided as well. Those are going to be great, valuable resources. Let me just double check. Yes, and Andre and Dylan both shared their LinkedIn. So if you have questions that we did not cover in today's session, please feel free to reach out to them. We provided their LinkedIns. You can continue that conversation with them as well. And we've got, they didn't get shared, but yeah, double check now. There should be some handouts available in the resources section available for download. Please take the time to download those great resources. They are fantastic. And we might have one more question. Oh, that was the one that was, we're going to let that be the last question. We will let that be the last question. And so let me just double check. All right. I just want to make sure nobody else had any last minute questions before we close out. Any final thoughts that Dylan and Andre, while we've got, a couple of minutes that you want to share last minute before we close out officially?
On my side, all good. I think we had a really great discussion. I love all the questions at the end there.
Yeah, I think the only last thought I'd have is that, reliability is an ongoing thing. It's unfortunately not just something that you can do once and say, we did it, now we're done. But the benefits of it are immense. I'm not just saying that because I work for a reliability company, but as somebody who uses a lot of this technology too, focusing on reliability is super important. So thank you all for coming out and for hanging out with us and for asking these great questions. Appreciate it.
Yeah, absolutely. I always say that, in order to build resilience, you've got to focus on reliability and structure. So awesome. Well, great resources today. This has been such a good conversation. Happy to have you back, Andre. Dylan, thank you so much for joining us with AWS. And just a few reminders again, this session has been recorded. It will be available afterward on demand, so make sure to check your emails for a copy of that recording. Please don't forget to download those resources, great resources from the team at Gremlin. And most of all, I just want to thank Dylan and Andre for joining us today. This has been fantastic. Thank you so much for joining.
Yeah, thanks for having us.
Awesome. And then last but not least, we invite you to please take our surveys just 1 minute. We'd love to have the team back at Gremlin, love to have AWS back. Dylan, love to see you again. And with that being said, thank you all for joining us today. And we are going to close out today's session. We hope you have a good rest of your day. Thanks for joining.
Thanks, everyone.
Take care.